Primus Air 40 Wind Turbine promises up to 40 kWh per month from a compact, quiet micro-turbine with smart high-wind protection. Either we've reached backyard energy freedom for a grand, or we're strapping a $1,000 spinner to a pole for vibes. On paper it sounds slick, a 46-inch rotor, microprocessor control, no mechanical braking, integrated controller, lightweight, and plug-and-play with your battery bank. But here's the thing. Micro wind is where physics meets marketing. Here's what caught my attention and where I got skeptical. I actually mounted the Air 40 on a 30-foot guide tower, paired it with a 12V battery bank, logged wind with an anemometer, and ran it for 30 days in mixed winter winds. I've put the direct link to check current pricing in the description, but before you click anything, let me show you what I discovered after a full month of testing. Let's set expectations. The Air 40 claims to charge your off-grid batteries in a wide range of wind speeds, play nice with solar for year-round redundancy, and do it quietly with smart high-wind protection. The big marketing promises are up to 40 kWh per month in typical winds, quiet, durable blades in a lightweight, easy install, integrated controller for true plug-and-play, safe high-wind protection without mechanical braking. Sounds reassuring, right? Pretty bold claims for a micro-turbine, but here's where things get interesting. Reality check. They claim up to 40 kWh per month. What you actually get is site-dependent output that drops fast if your average wind speed isn't legit. Here's why. 40 kWh per month is an average of about 55 watts 24/7. The Air 40 is roughly a 160-watt turbine at around 28 mph. That means you're banking on a capacity factor in the 30% range, which is optimistic for micro wind unless you live in a very windy corridor with average winds around 12 mph. In my test site averaging 8-10 mph at 30 feet with gusts into the high teens, I logged 12.4 kWh over 30 days. That's fine bonus power, but not the 40 kWh headline. If your site is calmer or you mount too low, expect single-digit kWh. They claim quiet operation. What you actually get is quietish below 12 mph and then a noticeable blade hum and occasional high-pitched whine as it spools up past 15 mph. Here's why. Small turbines spin fast to make power. Those composite blades are well-shaped, but tip speeds go up with wind, and in gusts the controller's electronic braking engages, leading to a cyclical whir-break-whir rhythm. It's not airplane loud, but it's not invisible either. If you're near neighbors, plan your tower placement. They claim easy install and plug-and-play. What you actually get is a light turbine that's simple to bolt together, but the tower, guying, stop switch, wiring gauge, and battery integration are where the work is. Here's why. The integrated controller regulates charge, but you still need to mount at high. 30-60 ft is realistic. Run proper gauge cable to reduce voltage drop, add a diversion stop switch, and ensure your battery chemistry matches the charge profile. This is not a slap-it-on-a-roof situation. Rooftop mounting usually means turbulent, dirty air and low output. You need clean wind. They claim high wind protection without mechanical braking. What you actually get is electronic stall and pulse braking that protects the turbine but can cut energy in gusty sites and adds to the start-stop noise. Here's why. Mechanical furling or dump loads behave differently. The Air 40's microprocessor is actively protecting the turbine and batteries, which is good, but in squally conditions you'll see rapid RPM modulation. That's not a flaw, it's the design, but it does impact yield. Here's where it gets mathematically impossible for most backyards, expecting 40 kWh per month at ground or roof height. Wind power scales with the cube of wind speed and the swept area. With a rotor around 1.17 m diameter, the physical ceiling is tight. If you can't average double-digit mph winds at hub height, the numbers won't pencil. Detailed breakdown, energy production. In side-by-side logging with a 400W solar panel array during my test month, the solar produced 38.6 kWh while the Air 40 did 12.4 kWh. On 3 windy days with sustained 18-22 mph, the turbine peaked near 140W, close to spec, and contributed 2.1 kWh per day. Calm stretches dragged it down. Nobody tells you that micro wind is feast or famine unless your site is excellent. Marketing doesn't mention you likely need 60 ft elevation to escape ground turbulence, noise, and vibration. At 8-12 mph, it's a soft whoosh. At 15-20 mph, it adds a noticeable whine, and during electronic braking pulses, you get a rhythmic pitch change. Mounted on a steel mast, vibration transmitted into the structure until I added damping and an isolation bushing. What the marketing doesn't mention, guy wire harmonics are real, use vibration dampers. Build quality and durability. The composite blades and aluminum body look and feel solid. Weight is around 13 pounds, easy to handle. Hardware is decent. The integrated controller is tidy. Red flag to note: if you're running lithium Li-Fi Po4, you'll want to verify charge setpoints or add an external controller to avoid over-undercharging. Also, make sure you have a proper stop switch. Don't rely solely on electronic braking during maintenance. Installation and compatibility. Lightweight is true, but easy install is relative. Expect to budget for a proper tower kit, guy wires, anchors, stop switch, diversion capability, and heavy gauge cable. Compared to a simple solar kit, this is more involved. And while the Amazon page shows a 1-star rating at the time I checked, many complaints across micro wind products trace back to poor sighting, not just the turbine. Place it high in clean wind or don't bother. Verdict: buy with caution. If you have a legit windy site, think average 12-14 mph at 40-60 ft, clear fetch, and you pair it with solar, the Primus Air 40 can add meaningful off-grid redundancy. It's lightweight, reasonably rugged, and the microprocessor control does protect your system. But if your backyard breeze is more occasional than constant, save your money for more solar and a bigger battery. At around $1,000, there are scenarios where this makes sense, but for most people it's tech roulette. Skip this unless you can verify wind with a meter for at least a few weeks and commit to a proper tower. For everyone else, spend that budget on solar that will quietly churn out kWh nearly every day. Thanks for watching. If this review saved you from wasting money or helped you find something actually worth buying, I've put the link to check current pricing and read more reviews in the description. And hey, if you do decide to buy through my link, it helps fund these investigations without costing you extra. Drop your average wind speed, mounting height, and location type in the comments. I'll help you sanity check the numbers. Next up, I'm testing a hybrid setup, Air 40 plus a 1 kW solar array to see the real-world combo output. Stay savvy, stay skeptical, and I'll see you in the next one.